Hey, my name is Avery, and today we're going to be going over 3 problems that deal with limits and horizontal asymptotes when it comes to rational functions. So as you can see, I already wrote out the problems in the work forum, and I'm just going to go through and explain them. So in this first problem, we're trying to find the limit as x approaches infinity for the function 3x squared minus 5x minus 1 over 2x squared plus 4. And I did a little pseudo graph right there just so we can kind of get an idea of what the graph is going to look like. And here we're just going to look at our rules for horizontal asymptotes. In this case, the degree of our numerator is equal to the degree of our denominator. And so in this case, to find your horizontal asymptote, you would simply find the coefficient of this leading term in the numerator and divide it by the coefficient of the leading term in the denominator. And so in this case, 3 from 3x squared over 2 from 2x squared gives you a horizontal asymptote of 3 over 2, which is also our limit. So as x is approaching infinity on this right side, you can kind of see our y value is getting closer and closer to 1.5. For problem 2, we're trying to find the limit as x approaches negative infinity for the function 3x to the 5th minus 5x minus 1 over 9x squared plus 1. And once again, I just drew out the function so we could kind of get an idea of what it looks like. And in this case, the degree of our leading term in our numerator is higher than that of the denominator. And so this means that there is no horizontal asymptote, and you can see that in the graph. There's not a single y coordinate that our graph is particularly approaching. So in this case, the limit does not exist. Also, I'm sorry for my shaky hands, but our last problem, I wrote it backwards, but we're trying to find the limit as x approaches infinity for the function 3x squared minus 5x minus 1 over 2x to the 7th plus 4x minus 1. So in this case, the degree of our leading term is less than the degree of our leading term in the denominator. And so the rule for that means that the horizontal asymptote of the function is 0, and that's also what our limit is going to be, is 0. So you can see here in the graph, as x is approaching infinity on this right side, this part of the graph is getting closer and closer to 0.